Hey guys, it's Mr. Bell. Hope all is going well at school. You guys have heard I'm in jury duty, which is going swimmingly. Um, Working on a fairly scandalous case where I'm pretty sure Colonel Mustard did it with the candlestick. But I'll hold my judgment for the time being. Anyways, if you guys wouldn't mind, please turn to page 11 in your blue books. We're continuing with our studies on the human population. And last week, we actually got into predicting where populations are heading, right? We use those age structure diagrams, and that serves as a really important tool for determining the momentum for growth or decline. In addition to using that visual graph, we can also calculate, right? We can quantify change. And so we're going to get to know some of the major population equations that we need to know for this class. There's not many equations that you have to memorize for apes, but most of them are found right here. So let's create a quick grab bag of the important equations you need to know for this unit and get to use them so we know how to manipulate them. And what I think you'll like about them is they're fairly easy to manipulate. They're not too tricky. Okay, so here's your major equations. First of all, when we think about calculating a population, we need to know sort of what the variables are for population growth or decline. And there's really 4 variables, and they can be classified as either inputs to the population, such as births, or those coming into a population through immigration, and then the outputs to a population, which would include deaths and those leaving a population through the process of emigration. So with that, we can easily calculate population change. And a change in the population is simply the inputs minus the outputs. We can also calculate a population percent change. Just like calculating any percent change, it's simply going to be the new population minus the old population divided by the old population. And of course, that's multiplied by 100 as it's a percent. Okay, we're not only concerned about change, but we're also very concerned about how quickly change takes place. And so therefore, we want to calculate what we call growth rate. And there's a couple different ways we can do it. For a country, we can calculate growth rate because there's going to be both natural and artificial inputs to a population, as there will be births and those coming into a country or into a population through immigration. And we simply subtract the outputs, deaths and emigration, to compare how quickly that is happening relative to the total population. You simply divide it by the total population times 100. Of course, when we're calculating growth rate for the global population, we call that a natural growth rate because there are no immigrants or emigrants to planet Earth. So it's simply the natural inputs, births, minus the natural deaths, the outputs. Divide that by the total population times 100 will give you your growth rate. Demographers, however, don't like to be burdened by these large numbers. They find them a bit too cumbersome, and rather they use crude values. They like to take statistically viable samples from the population. And so crude values are out of 1,000 people. For example, how many births for every 1,000 in a given year? How many deaths for every 1,000 people in the population? So we can calculate a crude growth rate simply by subtracting the crude deaths from the crude births divided by 1,000, which is the sample of the population, times 100. To simplify that, to make it quite easy to calculate, and maybe without a calculator, you can get rid of a whole bunch of zeros, right? So for example, take the 2 zeros off the 100, take 2 zeros off the 1,000, and you simply have crude births minus crude deaths over 10. Use what you're ever comfortable with. Once you know growth rate, we can then calculate the doubling time for the population. So for example, let's pretend we had 40 births for every 1,000 people and 20 deaths for every 1,000 people. With that, you can calculate the crude growth rate. 40 minus 20 divided by 10 will give you a growth rate of 2%. Once you know the growth rate, the percentage at which the population is growing, we can simply plug that value into the magical number 70. And this is always on AP exams, and we call it the rule of 70. 70, when divided by the growth rate, will give you the approximate doubling time for the population. So for example, a population growing at 2% divided into 70 will be doubling every 35 years. Your final equation has to do with population density. And just like any other density, it's mass divided by volume, but in this particular case, it's the population, the number of people, divided by the area in which they live, kilometers squared, for example. By calculating that, we can start to get to know and predict what some of the environmental impacts might be and whether they're going to be population dependent or independent population controls. All right, guys, that is it for your equations. Those are the major ones. So if you guys turn to page 12 through 14, you will find a tutorial on how to use these equations. Work with a partner if you'd like, work with a calculator. When you're done, your substitute teacher will show you the correct answers. All right, guys, good luck, and we'll see you soon.